The topic radioactivity. And radioactivity is simply defined as spontaneous disintegration of unstable atomic nuclei with the emission of alpha, beta, and gamma rays, and also energy with the release of energy or heat. That is radioactivity. So, alpha is represented, this alpha particle is represented as helium atom, while beta particle is equal to 0 minus 1 beta or 0 minus 1 E. That is how beta is represented, while gamma particle gamma is represented as 0, 0, the symbol of gamma, because gamma doesn't have any charge. It does not affect atomic or mass number, and it is not deflected by electric or magnetic field. It doesn't have any charge. So that's why it is neutral. It does not affect either electric or magnetic field. It is undeflected and it doesn't have any charge. It does not also affect the atomic number or the mass number of an element during the disintegration or the decay. So, for example, this is thorium. It has atomic number 90 and it has mass number 232. When it disintegrates, it became radium, which has atomic number 88 and mass number 228, plus helium or alpha particles, plus the gamma rays, which is neutral, which does not have any charge. So, and this is radium. Radium decays to radon. Radium decays to radon by alpha particles emission. Look at it. Radium, it is 88 in atomic number. It decays to radon, which is 86 in atomic number, and it's also emitted alpha particles, which is helium atom. So if the element disintegrates with emission of beta particles, it is transformed into another element of atomic number, Z plus 1. It's transformed into another element of atomic number with Z plus 1. The mass number remain unchanged. Look at it. This is radium. When it disintegrates, it became, this is 88 in atomic number, that is Z plus 1, it became 89, and the new product is actinium, but the mass number remains unchanged, 228. The first mass number of radium is 228, and still it is 228, so it remains unchanged, plus the beta particles. Then radon decays to radium. Radon decays to radium by 2 beta particles emission. That is, now this is radon. This is radon. It becomes to radium plus 2 particles of beta. That is 2 beta particles. So radon is 86, but radium is 88 in atomic number. So when radon disintegrates, it became radium plus 2 beta particles. Then the emission of gamma ray does not by itself affect the atomic number or the mass number. It doesn't affect the atomic number or the mass number. So we have 2 types of radioactivity. We have the natural radioactivity. We also have the artificial radioactivity. Starting with the natural radioactivity. Natural radioactivity is the spontaneous disintegration or decay of atomic or unstable atomic nuclei or any of the radioactive elements with emission of alpha, beta, or gamma particles, or the combination of all of the 3 with release of energy or heat, that is natural radioactivity. Example. So this is natural radioactivity. Natural radioactivity is the spontaneous disintegration of the nucleus of an atom during which the alpha, beta, gamma rays are emitted or combination of all of the three. It can combine all of the three. That is alpha, beta, and gamma rays with release of energy. So that is natural radioactivity. For example, this is radium. When it disintegrates, it becomes radon plus alpha particles plus the energy. Then this is radon. When it disintegrates, it becomes radium plus beta particles plus energy. So if the radium loses gamma rays, a negligible mass is lost. Since the gamma rays does not have any charge. Now new element is formed. Also uranium atom. When uranium atom decays by emitting two, it will emit two particles, two beta particles, two alpha particles, and thorium plus the energy. That is, the equation is this. This is uranium, which has atomic number 92 and mass number 238. When it disintegrates, alpha particles, two particles of alpha are emitted, two particles of beta are emitted, and thorium plus the release of energy. Energy is released plus thorium, which is 90 in atomic number. It has atomic number 90 and it has mass number 230. So these are some of the examples of natural radioactivity. So I'm going to stop at this point. In the next one, I'll continue with artificial radioactivity. I will explain the artificial radioactivity, and I'm also going to write examples under it. I'm going to state some examples under it. We call it a day.